Uh, yes. Good morning to all. This is Anvesh, and I'm from AAA branch. And now I just want to explain uh, Davison German experiment. So I'll not use PPTs, but I'll say by orally, by my own, so that can understand very well. So, what is Davison German experiment? You know, de Broglie pass a statement that every moving object possesses a wave. I mean, every moving object is a wave. So he did not did any experiment to prove this. So our Davison German experiment uh, to uh, uh, to for mm, I mean to be far with what De Broglie says. Uh, the main motto of this Davison German experiment is uh, fast moving electrons shows deflections. So uh, it is the introduction part. What I said is this, and now you coming to this. I mean, sorry. Yes. If you see this, I took uh, I took a tungsten here uh, because it shows. It is why I took tungsten means it is a fast heat grasper. I mean, it heat fast. I took a low terminal battery to the tungsten filament, so it produces the heat. I mean, it produces the heat, so heat fastly. So I took a low terminal battery to the tungsten filament. It means uh, the heat is coming out of the tungsten, and I put a barium oxide to that filament. I mean, to the tungsten barium oxide, which means it electron emitter. I'm an electron emitter. It the it will uh, it will possess electrons with that heat. So the uh, so we put a barium oxide beside the tungsten. So uh, now the heat will be into the barium oxide, and uh, the electrons will be out from that barium oxide, and there is a chance of electrons going around, but we want that electrons in a beam path. I mean, it need to be in a beam. So for that reason, we took a cylindrical shape like this, and we gave a high terminal battery to the cylindrical shape, and we put a hole to the front side to the back side. I mean, between two sides. So when we put the high terminal battery, it it possesses high voltage. It means that the electrons will be passes through that hole. I mean, like a beam of light. So those electrons will not be escape uh, from that cylindrical shape. I mean, it goes to the cylindrical shape, like structure. If you see there, it goes through that, and it pos- uh, and it passes the light rays like a beam. And we put nickel crystal here. Why I put nickel crystal means because it need to be make a some angle. So when I put a nickel crystal, it will bounce back. I mean, it bounce back. So we put a galvanometer, which it is in circular motion, because we need to know at which angle the electrons will show uh, high deflections. So we took as alpha, I mean phi here, the angle. So uh, I think so you need I think you have understood this. You have understood this setup, whatever I say. So I just want to repeat once again. I put a tungsten filament and I took a low terminal battery which passes the heat very fastly, and I took a barium oxide beside the tungsten, which means the electron is emitter, and we put a cylindrical shape like uh, this, which means a beam of light passes through that. We gave a high terminal battery to that. So and we put a nickel crystal where electrons will uh, go and emit backside. So at the angle where the galvanometer shows the deflections. So uh, so this is the setup. So I think you have understood. So this is the procedure what I just explained to this. So if you read this, you can understood more what I said. So if you see here, uh, if you see, I just make an angle phi there, but we want what are the observations for that. So coming to observation, if you see at a 0 degrees, it shows some deflection. I mean some volts. If you see the 20 degrees, it shows some more than the 10. At more than at 30 degrees some, at 40 degrees some, at 50 degrees. But coming to 50 degrees, it shows 54 volts. But after 60 degrees, it decreases. It means at 50 degrees it shows high deflections. It means at 50 degrees it shows 54 volts. So after that it is again decreasing, the volts are decreasing. So from this observation, from this setup, we have observed that at 50 degrees, at 50 degrees, uh, we observed a maximum volts like 54 volts at the maximum 50 degrees phi, where the angle is phi. If you see the setup, we need to draw a right angle triangle like this, and where the theta will be phi plus uh, theta equal to 90, where phi is the 50 volts. So 50 will be go that side, and 90 minus 50, so the theta is 60. So this is the reason why we took the theta value as 50. I mean not 50, I mean for 40, sorry, I think so it is 50 degrees, I think so. So next, so this is the observation what I told you this. So yeah, if you see the graph over here, at 40 volts it shows like this, at 44 volts it shows like this, at 48 volts it shows like this, and at 54 volts it shows like this. It means at a 50 degrees angle it shows like this. Okay, at 60 degrees it's becoming low. Okay, you can observe this graph here. So you need you can understand more. Yes. Yes. Yeah, now I just understood that. uh, yes, I said no. We make 90 minus 50 by 2. It means 90 minus 25. It means the angle will be 90 minus 25 means somewhat like 65 degrees. Yes, 65 degrees. So we'll take the theta as 65 degrees because we took an angle phi there. Uh, so the theta will be 65 degrees to that. So if you see the problems, we are so many problems. So I think I have executed well. uh, at lastly, the Davison German experiment was uh, the satisfied the de Broglie's statement, which the light which every moving particle uh, is a wave. So thank you for all.